Let's quickly look at this past exam question on production function. For the production function below, assume that fractions of the units of k and l can be used. Q is equals to 9k raised to the power of 0.5 multiplied by l raised to the power of 0.5. Q is equals to 36. We are asked to derive a function for the isocant representing the specified output level in the form k is equals to fl. And question 2, we are asked to find the level of k required to achieve the given output level of L if L is equals to 100. You understand? Okay, now let's start by writing out the production function. We are given that the production function Q is equals to 9k raised to the power of 0.5 multiplied by L raised to the power of 0.5 and Q, they give us that Q is equals to 36. Okay, now the first question, please, I want to pay attention. Okay, I want to pay attention. The first question, we are asked to derive a function for the isocant representing the specified output level in the form k is equals to f of L. Do you know the meaning of this? That is, we are asked to make k the subject of the relation. You understand? They want us to derive the production function that look like this. You can see that k is at the left hand side of this equation. K is a function of L. Therefore, we are asked to make k the subject of the relation. You understand what I'm saying? So let's go back to our production function. Our production function is what? Q is equals to 9k raised to the power of 0.5 and L raised to the power of 0.5. Now, Q is equals to 36. So I'm going to have 36 is equals to 9k raised to the power of 0.5, L raised to the power of 0.5. Now, the next step now is to divide both sides by 9. I'm very sure you understand. Okay? The aim here is to make k the subject of the relation. You understand what I'm saying? So for this, I'm going to have all this divided by 9 and this divided by 9. So I'm going to have 36 divided by 9, that is 4. So I'm going to have 4 is equals to k raised to the power of 0.5, L raised to the power of 0.5. Do you understand? Okay, having gotten to this place, I can, by transposition, I can have something like k raised to the power of 0.5, L raised to the power of 0.5 is equals to 4. You understand? I've not done anything. I just interchanged the left hand side and the right hand side of the equation. Now, the next step here is that, okay, let me write it here. K raised to the power of 0.5, L raised to the power of 0.5 is equals to 4. Okay, the next step right now is to divide both sides by L raised to the power of 0.5. You know that my goal is to make k the subject of the relation. So I want to make k to stand alone. You understand what I'm saying? So I'm going to divide both sides by L raised to the power of 0.5, L raised to the power of 0.5 all over L raised to the power of 0.5. So in the left hand side of this equation, I'm left with k raised to the power of 0.5 is equals to 4 all over L raised to the power of 0.5. Now, I want you to pay attention. I want you to pay attention here. You know, k, look at this. K raised to the power of 0.5 is equals to k raised to the power of 1 over 2. You understand? Because 0.5 is 1 over 2. Do you understand? Now, if k raised to the power of 1 over 2, k raised to the power of 0.5 is k raised to the power of 1 over 2. I can square both sides. You understand? If I square both sides, I can eliminate this 0.5. You understand? Please, I want you to pay attention. If I square both sides, I can eliminate this 0.5. So I'm going to have k raised to the power of 1 over 2 squared is equals to, let me square this 4 over L raised to the power. Also, L raised to the power of 0.5 can be written as L raised to the power of 1 over 2. Okay, let's square it. Please, do you understand how I got this? Okay, now k raised to the power of these 2 can cancel these 2. You understand? So I'm left with k. K is equals to, now for the left hand side of this equation, 4 over L raised to the power of 1 over 2. That will be 4 all over L raised to the power of 1 over 2 multiplied by 4 all over L raised to the power of 1 over 2. The reason why I go this long way is because I just want to show it to you how arrive at my answer. You understand? If I'm solving this in the exam, I will just, do some shortcuts and then get my answer. You understand what I'm saying? So, but I show this to you so that you will understood how I arrive at the answer. Okay. Now, for this, I'm going to have k is equals to, now, for the numerator, 4 multiplied by 4 will give me 16. You understand? Please pay attention. 4 multiplied by 4, that is 16, all over. Now, according to the law of indices, if I have a raised to the power of 2, let me say a raised to the power of 1 times a raised to the power of 1, that is what? A raised to the power of 1 plus 1, which is what? A raised to the power of 2. If I have a raised to the power of 1 over 2 multiplied by a raised to the power of 1 over 2, that will be a raised to the power of 1 over 2 plus 1 over 2. Then I'm going to have a raised to the power of, LCM is what? 2. So I'm going to have 2 plus 2. Oh, sorry. 1 plus 1. That is a raised to the power of 2 over 2, which is what? A. A raised to the power 1. You understand? A raised to the power 1 is still the same thing as A. You understand? So now, L raised to the power of 1 over 2 multiplied by L raised to the power of 1 over 2. Let's do it. L raised to the power of 1 over 2 multiplied by L raised to the power of 1 over 2. According to the law of indices, I'm going to have L raised to the power of 1 over 2 plus 1 over 2. Now, from that power, I'm going to, the LCM is what? 2. 2 divided by 2, 1. 1 times 1 is what? 1 plus 1. So I'm going to have L raised to the power of 2 all over 2, which is the same as what? L raised to the power 1, which is L. Do you understand how I got this? So, L raised to the power of 1 over 2 times L raised to the power of 1 over 2, that is what? N. Do you understand? So, now, from this point, I can rewrite this as K will now be equals to 16N raised to the power of negative 1. You understand? Please pay attention. K is equals to 16 over N. We can rewrite this as K is equals to 16 multiplied by 1 over L. Then K is equals to 16 multiplied by L raised to the power of negative 1. You understand? Because 1 over A can be written according to the law of indices. These are basic mathematical concepts that you're supposed to understand. If you didn't understand, you can check the channel for there is a video that I did on the indices. You understand? You're going to see all this law there. So I use the law of indices. So the function that I am asked to derive, this is the function. K is equals to 16 raised to the power of negative 1. So now I have derived the function. The question I posed that, I'm coming, let me quickly check the question. The question I posed that we should find the level of K required to achieve the given output level of L if L is equals to 100. We are asked to find the level of K required to achieve the given output level if L is equals to 100. Now, I have known that the production function that they want me to derive is K is equals to L raised to the power of negative 1. Now, I'm asked to determine the output level, the level of K required to achieve the given output if L is equals to 100. The next thing is that I'm going to substitute the value of L as 100. You understand? So, for question number 2, that is Roman figure 2, K is equals to 16L raised to the power of negative 1. Now, since L, they gave us in the question that L is equals to what? 100. So, when L is equals to 100, so K will be equals to 16 multiplied by 100 raised to the power of negative 1. Do you understand? Because they asked me to find the value of K when L is equals to 100. That's the summary of the question. You understand? So now, for this, I'm going to have K is equals to 16 multiplied by 1 over 100. Don't forget that 1 over 100 is what? 0.01. So I'm going to have K is equals to 16 multiplied by 0.01. Then K will be equals to, now, if you multiply 16 by 0.01, that is 0.16. That is 0.16. So the output level, please pay attention. This is the, you can now interpret the question as this. The level of K required to achieve the given output level if L is equals to 100 is K is equals to 0.16. Do you understand? Okay, that is the solution to that question. See you in the next class. To watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay, see you in the next class.